Hello students, good morning. So as you know, we are switching with the chapter System of Particles and Rotational Motion, and we have started up with some basic things. So as you know, we are dealing with center of mass. So and also we have derived the position vector of center of mass and its integral form also. So moving on, today we will deal with motion of center of mass, linear momentum of a system of particles, and vector product of two vectors. Okay, today I'll try to complete a maximum amount of points among these things. Okay, so moving on, the first thing, motion of center of mass. Okay, you already know very well that how the center of mass will be, and what is its significance, and what are the positions, what are the position vector, what are the coordinates of center of mass. All those things we have discussed from our previous classes. So today we'll discuss about how or which forces or which parameters are there relating to motion of center of mass. Like we are considering the mass of the particles, we are considering the velocity, acceleration, forces, all those things. Okay, so let's start. So from the previous classes, you know that the position vector of a center of mass can be given as, so this is the position vector r of center of mass, and that can be written as summation mi ri whole divided by m. Okay, this expression, which we given the name equation number 8 in our previous derivation, this indicates position vector of center of mass. Okay, where this mi is the mass of ith particle, ri is the position vector of ith particle, and m means what? Capital M indicates what? Summation of mi, means all the small particles, all the small masses, if we taken the summation, we can write it capital M. So this is the position vector of center of mass. So I is nothing but what? I is equal to, we can give the values up to from 1 to 3 and so on up to n. Okay, so this equation, I'll just change it as, I'm transferring this m to this side. M into r is equal to summation mi and ri. Okay, just rearranging the terms from this expression. Okay, so this summation, now you just forget about this, you just think of this summation mi ri is nothing but what? Is it m1 r1 plus m2 r2 plus m3 r3 and so on up to mn rn? Yes, means in our previous explanations we just replaced this long term where we considered n number of particles, we got the expression like this. So this thing we just replaced by using the summation and using the ith particle. So this only I am writing in a expanded form. Okay, so this can be written as m1 r1 plus m2 r2 plus m3 r3 and so on up to mn rn, because we are having the particles 1 2 3 so on up to n. So let's call this as equation number 1. Okay, next, differentiating both side of this equation 1. What we will do, we'll just differentiate, means from this equation can we write mr is equal to, means if this is equal to this explanation expanded form, then this can be equal to mr. So mr is equal to m1 r1 plus m2 r2 plus m3 r3 and so on up to mn rn. Okay, this is nothing but what? Equation number 1. We are differentiating this equation number 1 with respect to time. Okay, on both the sides. So with respect to time, this m is what? Constant. R is the variable. So differentiate R with respect to time. Same thing on RHS also. M1 as it is dr1 by dt plus m2 dr2 by dt plus m3 dr3 by d3 and so on up to mn drn by dt. Okay, understood up to here? We are just taking that expression which we got in the last derivation and just rearranging the terms and expanding this summation mi, hence this can be equal to this. So we are applying the differentiation on both the sides of this equation, hence we get this term. Okay, so this dr by dt, whatever is there, dr by dt, r is nothing but what? Position. R here also position, r is also position. So when an object is changing with its position with respect to time, that clearly means what? It is under motion, right? From the basic things we know, the rate of change of position is nothing but motion, or the rate of change of displacement. Position is changing means what? Any object, if it is here, it is changing its position from here to here, means initial position is A and final position is B. So when the position of the object changes from A to B, it undergoes motion. So that change of position is nothing but what? Displacement, right? Displacement from A to B. So this rate of change of displacement with respect to time is nothing but what? Displacement divided by time is nothing but what? Velocity. Displacement divided by time is nothing but velocity. So can I just write this as m into capital V? Yes, rate of change of displacement is means position is changing is nothing but what? Displacement. So the change of displacement with respect to time is nothing but velocity. So instead of dr by dt, I'll keep on writing the velocity. So this m1, here we are having small r, that's why what I will write? V1, small v1, plus m2 small v2 plus m3 small v3 and so on up to mn vn. Okay, now this is our equation number 2. This is our equation number 2. Okay, so this v1 is equal to what? dr1 by dt. v2 is equal to dr2 by dt. vn is equal to drn by dt. So all these things are what? Velocities. So v1 is the velocity of first particle. v2 is the velocity of second particle. vn is the velocity of nth particle. Understood? And v, this capital V is the velocity of what? Velocity of this r is position of what? Center of mass. Hence this v is also velocity of center of mass. Now again what we are doing? We are differentiating the equation 2 also. Again applying differentiation on both the sides of equation 2 with respect to time. So again keeping m as it is, because mass will not change with respect to time. Mass is a constant, it is not changing, but the position, velocity are changing. So we are keeping mass as it is. dv divided by dt, differentiating this dv also, and similarly here what happens? m1 dv1 by dt plus m2 dv2 by dt. Okay, I hope this is properly visible. Okay, and m3 dv3 by dt and so on up to mn dvn by dt. Okay, so as we said that dr by dt is nothing but what? Dr by dt was velocity. So means displacement is changing with respect to time, means that is velocity. So what if velocity is changing with respect to time? Rate of change of velocity with respect to time is nothing but what? Rate of change of velocity with respect to time is acceleration, right? So this m is equal to m into a, capital A. dv by dt is nothing but capital A. Similarly for m1 dv1 by dt, small v1, dv1 by dt is a1. m2 dv2 by dt is a2. m3 dv3 by dt is a3, right? So up to mn dvn by dt is an. Okay, where this a1 is equal to dv1 by dt is acceleration of first particle. a2 is equal to dv2 by dt is acceleration of second particle. a3 is equal to dv3 by dt is acceleration of third particle, right? And at the last an is equal to dvn by dt is acceleration of nth particle. Similarly here what happens? Capital A is equal to dv by dt, capital V. So this is acceleration of what? Center of mass. Okay, so can we just write this a1 is equal to what? Means m into a we are having. Okay, m into a means m1 into a1, m2 into a2, m into, it means in general what we have? M into a, product of mass and acceleration according to Newton's second law. What is product of mass and acceleration? Is it F force F is equal to ma? Is it Newton's second law? Yes. So can we write m into a as F small m1 into a1 small f1? Otherwise instead of writing small f1 we can write this only, because we are having this f1 f2 are the components of capital F, means the total F, right? So m3 into a3 f3 plus and so on up to mn into an is fn. Okay, so keeping this m into a as it is, because we want the last result in terms of m into a. We want the last result in terms of m into a. So see here students what happens. This product of total mass of the system of particles and the acceleration of center of mass. This m into a is nothing but what? M is what? Total mass, which you have already told like this, right? M into I, summation mi is equal to capital M. It is the total mass of the system of particles. Okay, total mass of the system of particles, and A is the acceleration of center of mass of the particles. Okay, so this product of m into a, it is nothing but what? The vector sum of the forces acting on the system. So this F1 is what? Force acting on the first particle. F2 is force acting on the second particle. F3 is force acting on the third particle. Like that, we are having number of forces acting on each particle of the system. Because theoretically, if you want to say here, if it is one particle is there, 1 particle, 2 particle, 3, 4, 5, 6, up to that n number of particles we are having, right? So this first particle is having the mass m1, is having the position r1, is having the velocity v, v1 is having the velocity, means mass is m1, position is r1, rate of change of position is nothing but v1, rate of change of velocity is nothing but a1, and product of mass and acceleration is nothing but f1. So the force acting on the first particle is f1, force acting on second particle is f2, like that f1, f2, f3, f4 up to n numbers, up to fn we are having. So here we are having the vector sum of all the forces acting on this whole system, right? Small f1 is first particles force, f2 is second particles force. So if you combine all those forces, can we say this as the total force acting on the whole system? Right. So this product of mass of the total mass of the system of particles is and the acceleration of center of mass is equal to the vector sum of all the forces acting on the system of particles, right? And these forces f1, f2, f3 up to fn are the external forces acting on the particles. These are the external forces, not internal forces. Means force is not developing inside the object, force is exerted from outside. So they are all what? External forces acting on the body. So we can write this f1 plus f2 plus f3 and so on up to fn as f external. Subscription I am writing ext, external, right? So from here we can write m into a is equal to f external. Okay, where this f external, we have to show the direction also because it is a vector. F external is the vector sum of all the external forces. A vector sum, F external is what? Vector sum of all the external forces acting on the particles, acting on the every particles of the system, right? Here we don't have any internal forces. Internal forces do not contribute to the motion of center of mass. Internal force do not hold any part in the motion of center of mass, but we are having the external forces. These are the vector sum of external forces. So this product m into a is equal to f external. Okay, so this is the expression we are getting. So here we can conclude one statement that the center of mass of a system of particles moves as if entire mass of the system is concentrated at the center and all the external forces are applied at the center of mass. Understood? No. Means here we are considering one system. Yes, here it is one system. So this center, at the center we are having one center of mass, na? Cm. So this center of the center of mass moves. How it moves? It moves as entire mass of the system is concentrated here and all the external forces are applied here only. Means the mass of the system, whole system is concentrated here, means all the forces are applying here only, na? That may be f1, f2, f3, like that. All the forces are acting here only. So this center of mass moves in a system as the entire mass is concentrated here and all the external forces are applied here only. Understood the meaning of this expression? This expression is what? Product of mass into the product of total mass of the system and acceleration of system of particles is equal to the vector sum of all the external forces. So this expression, how it can be explained means the center of mass moves as the whole mass of the system is concentrated here and all the external forces are applied here, right? This is about what? Center of mass. Okay, if you not understood anything, you can ask me. Okay, so moving on to the linear momentum of system of particles. The second part is, so this is completed. So next, linear momentum of a system of particles. Okay, so here in the linear momentum of a system of particles, what we are doing means we are considering same some n number of particles with the masses m1, m2, m3 and so on up to mn. N number of particles with the, sorry, let me adjust it properly. Okay, so n number of particles with the masses like this. Okay, and if in the last explanation we know that the center of mass is moving. So if it is moving, the all the particles are also moving. So if they are moving, what is the thing they refer is velocity. So every particle is having the velocity v1, v2, v3 and so on up to vn. Okay, so the linear momentum, what is the meaning of the term linear momentum means? Linear momentum means linear momentum is nothing but what? It is the product of mass and velocity of the object. Means if any object you are considering and you are considering its linear momentum, that is what? The product of mass and velocity of the object. So this linear momentum can be written as p. It is denoted as p is equal to mv. It is what? Linear momentum. So here we are considering the whole system's linear momentum as capital P. Means the whole system is there and in that so many particles we are having now. So the whole system is having the linear momentum capital P, and linear momentum of first particle is P1, second particle is P2, third particle is P3 and so on up to n. Okay, so this is linear moment of first particle. Okay, so how can we write the linear moment of first particle as P1 is equal to m1 into v1, because we know that mass of the first particle is m and velocity of first particle is v1. Similarly, mass of second particle is m2, mass of velocity of second particle is v2. Mass of third particle is m3, velocity of third particle is v3. So and nth particle is having the mass mn and velocity vn, right? So this p1, p2, p3 can be written as m1 v1, m2 v2, m3 v3. So here p is there. So p is nothing but what? m1, m2, m3. Instead of that, can we write capital M and V in general, right? So this is what? Linear momentum of the system of particles, and m is the total mass of all the particles of the system and v is the velocity of center of mass of the system. Okay, thus the total linear momentum of a system of particles is equal to what? The product of total mass of the system and velocity of center of mass. Okay, let's call this as equation number 1. Now differentiate this equation number 1 with respect to t, with respect to time. What happens? dp by dt, m as it is, dv by dt. Okay, so this m into dv by dt is nothing but what? We saw this in the last expression only. M into dv by dt is nothing but capital A acceleration, right? And this m, product of m into A is nothing but f external. We derived this in the last derivation, na? So if the total, so here we are having in the LHS dp divided by dt. So if, now if you consider that if there is no any force acting on the system, if there is no any external force acting on any system, means any particle of the system, hence there is no the external force acting on the whole system, na? Means if there is no f1 f2 f3 up to fn, then there is no f external. So if there is no any force acting on the system of the particles, then f external becomes equal to what? F external become equal to 0, right? If why we are considering there is no force acting on the particle, means here they are not under motion, right? They are not under motion. So this whole system of particle is not acted upon by any force, right? So the force F external becomes equal to 0. So if dp by dt equal to 0, means if dt by dt equal to 0, what p equal to? Means what do you will write? The differentiation of constant is equal to 0 you will write, na? In the differentiation, or means if m is one constant, the differentiation of constant is nothing but what? 0 you will write. So if differentiation of p is equal to 0, so p becomes what? Constant. So this p is nothing but what? Constant. Okay, so therefore what we can conclude here, that when the total external force acting on a system of particles is 0, the total linear momentum remains constant. When the total external force acting on a system of particles is 0, then the total linear momentum of that system remains constant. This is the law of conservation of total linear momentum of system of particles. Okay, you just, as I am saying the sentences, you just go on writing them also. Okay, what I said here, when the total external force acting on a system of particles is 0, then the total linear momentum remains constant. When the total external force acting on a system of particles is 0, the total linear momentum of that system remains constant, and this is called as what? The law of conservation of linear momentum of system of particles. Okay, so this is about what? Linear momentum of system of particles. So as I promised, today we are discussing the 3 concepts, right? Among them, first one is completed, second is completed. So the next thing is vector product of 2 vectors. So the next one is what? Vector product of 2 vectors. Okay, is it possible, visible clearly? Yes. Okay, so vector product of 2 vectors. So as we are saying here as, okay, so what is meant by vector? Means you already know that the physical quantity which is having both magnitude and direction is called as vectors. Means if A is one vector, it is written like this, because not only magnitude, means if A is not having a particular value, it is having one particular direction also. So this vectors, means when you start study about vectors, there is a big concept only, like we are having vector calculus, vector algebra, like that. Okay, so for our syllabus, what we are having vector product. Any 2 vectors we are considering, A and B, and their product, vector product we are discussing. Okay, now you just consider that vector product of these two vectors A and B is one more vector C. Means vector product dot product, you know na, dot product means A dot B and vector product means A cross B. So this is what? Vector product. So vector product of A and B is equal to C, you consider. Obviously C is also one vector. Okay, so here the vector product of two vectors A and B is one more vector C, such that 2 points will come across with. First point is what? This magnitude of C magnitude of C is nothing but what? Magnitude of C, or you consider magnitude of C is nothing but the product of magnitudes of A and B. The product of magnitudes of A and B and the sine of angle between the two vectors. Now if you consider the two vectors, vector A and vector B are here, and in between them we are having angle theta. So C is the product of A and B such that the magnitude of C, not direction they are asking, only magnitude, hence I have written only C, not direction, only A and B, not direction. So if C is the vector product of A and B, then the magnitude of C is equal to product of magnitude of A and B and the sine of angle between these two vectors. Understanding? The means the vector product of two vectors A and B is one more vector C such that its magnitude is the product of magnitudes of A and B and the sine of angle between these two vectors, that is C is equal to AB into sine theta. Okay, this is the first point. One more is, what is the direction of C? The direction, this is about what? Magnitude of C. The direction of C is perpendicular to the plane containing A and B. Now if you just consider that, A and means you can consider by how means you just consider my hand. Okay, this is A and this is B. This A and B are in one plane, means the plane of paper. A and B are in plane of paper, you consider. Okay, then the product of A and B was C. This thumb is what? Vector C. So the direction of C is perpendicular 90 degree. Perpendicular means 90 degree perpendicular to the plane containing A and B. Okay, so A and B, these A and B are lying in this plane, the plane in which paper is there na. A and B are lying in this plane, A and B, and C is perpendicular to that plane. A and B are lying in this plane and C is perpendicular to that plane, means C is at 90 degree to the plane of A and B, right? So the direction of C is perpendicular to the plane containing A and B, and it is given by the right hand rule or the right hand screw rule. Okay, means how? Means you just consider that, means right hand rule means what? If the fingers of your right hand are, means you just consider this pen I am having. Better I can explain this in theory only. Okay, you just consider this. This is what? Right hand screw rule. Right hand rule. Okay, means if the fingers of the right hand, are curled, if the fingers of our right hand are curled in one direction, means then the thumb is representing C. Means this, you just consider this is one conductor I am holding in my hand. Okay, and these fingers whatever are there are the directions A and B, are in the direction A and B, and this C is representing the what means this thumb is representing C. Okay, this is some theory part. I'll explain this in the next class only in detail. You just now consider these 2 points. First point is what is the vector product means. If A and B are any two vectors, then its vector product is C. C is also one more vector. C is the vector product of A and B such that its magnitude is given by this and direction is given like this. Means magnitude of C is nothing but product of magnitude of the vectors and sine of angle between them. This is magnitude of that C, vector product, magnitude. And direction means if A and B are lying in this plane, the C is held perpendicular. C is at a perpendicular direction to that plane in which A and B are there. So it can be given by the right hand rule or right handed screw rule. What is the right hand rule and right hand screw rule? I will explain in detail in the next class. Okay, so means today I just followed this paper and pen format because see, in motion of center of mass also and in linear movement of the particles also we had the lengthier points. Okay, which I'll start, if I start drawing on the board, they got much time and they are not that much comfortable for me, right? That's why I use this method today. So we don't had any theory part today, right? We don't have any theory part, we just have derivations. That's why I gone with this paper pen format. Okay, from the next class I'll explain one more time this right hand rule and right handed screw rule. Okay, so you just up to this introduction, up to what is meaning of vector product of two vectors only we'll discuss today. Other things we can continue in the next class. So today we explained about motion of center of mass, linear movement of center of mass, and vector product of two vectors. So vector product of two vectors is not finished yet, only just the meaning. What is vector product meaning only I told. Okay, I'll explain this in next class. So in all these parts, if at any point if you got any kind of doubts means you can ask me or you can message me in the WhatsApp. Okay, but don't be there with the doubts. First you just clear your doubts, then only you move forward. You don't stay blindly with your doubts. Okay, so I'll finish the class today. Next part I'll explain in the next class. Thank you.